Hello and welcome to the first video for Calculus 3. This is Math 233. We're going to be beginning with Chapter 2. That is all to do with vectors. So I first put up a couple different definitions that are from your book. The first of which is a vector is a quantity that is both a magnitude and a direction. So first of all, magnitude is the length of the vector. Often the notation for that, so for vector v, your book will typically bold these, so I'll either try to bold them or I may do something like that to illustrate that it's a vector as opposed to just some other variable. So for vector v, the magnitude is noted or is denoted as that. So you've got double lines, double vertical lines on both sides of the vector. That's what the magnitude is. So that's a symbol for it. So if you see that symbol, that's what it's looking for. Okay, so a vector has both an initial point and a terminal point. And we can draw one on this little graph here. So let's let A be the point, I don't know, 2, 2. Let's let this be our initial point. And let's let B be, I don't know, 4, 6, say. And this is our terminal point. So 2, 2 would be here on our graph, provided that these are 1 unit each. We'll just put that as A. And B would be 4, 6, so looks like right here would be B. And to draw the vector between these 2 points, just connect them with a straight line. And we draw an arrow in the direction of where our vector is pointing. So because the terminal point is 4, 6, it goes from 2, 2 to 4, 6. It's going in the upper right direction. And hence that's how we'll illustrate it with an arrow. All right, the other definition, we say that two vectors are equivalent if they have the same magnitude and direction. So essentially their slope has to be the same and they have to be heading in the same direction, which is going to be illustrated by slope. But the other thing is the magnitude, which is the length, has to be the same. So if I drew another line, say, just move it over a few, say this one, these two would be equivalent. So they're going to be parallel, they're going to be heading in the same direction, and they're going to have the same length. And I could shift this down, 1 or over more or whatever, and still be the same. So these two would be equivalent. One more thing I want to speak about vectors in this initial video would be the zero vector. And either a bold 0 or, again, a 0 with a line over it, is a vector that has the same initial point and terminal point. So it's, in effect, just a point. If the initial point and terminal point were both -1, -1, that doesn't have any magnitude. There's no distance to the point. And so we deal with the vector as being the zero.